rational function is a function that is a ratio of two polynomials, from which the denominator can be 0. The domain is a set of all possible input variables on x, while the range is a set of all possible input variables on y. The x-intercept is the point on x when y touches 0, and the x-intercept is a point on y while x equals 0. The vertical and horizontal asymptotes are lines that the trace graph of a function approaches but never touches.
Following situation: Matthias Smith, an aspiring ecologist and biologist, desires to obtain his PhD in sciences by doing a study of populations. For that, he wants to analyze the behavior of the population in a rabbit community near his city, and with that information, predict how the population will change in future years. He already knows by past analysis that the population of the community is modeled by the function pt, where t equals 1 represents the beginning of year 2001, t equals 2 represents year 2002, and so on. So here's our equation, which is p of t equals 3000t minus 2000 over t minus 0.5.
So here we have our graph. The x starts at 2001, 2002, 2003, and so on. The y starts from 1000, 2000, 3000, and so on. First, we're going to take the x-intercept. To do this, we're going to make the y a 0 in order to take the y-intercept, the t-intercept. We're just going to take the top part by taking this, the part from the bottom, and multiplying it by 0, it becomes 0. Then we're going to move the 3000t to the other side, making it negative. After that, we're going to take this 3000, which is multiplying the t, and divide it with the minus 2000. Leaving us with a t with a value of 2/3.
We are going to get the horizontal asymptote. We check the degrees, and the two are equals. There's two t's, so it's 3000 divided to 1, so it's 3000, the horizontal asymptote.
So in order to get the y-intercept, we're going to make the t a 0. So we're going to divide minus 2000 over 0.5, which this gives us minus 4000. Then we're going to get the domain. To get the domain, we're going to use the lower part, or the divisor of this equation, t plus 0.5, and make the other part of the equation a 0. 0 equals t plus 0.5. This is, then the t is going to go to the other side in a negative way. And we're going to make the t a positive, and it becomes a minus 0.5. So this number cannot be used in this part, as any division cannot be divided by 0. So x then is any real number except for minus 0.5.
So now we're going to factorize this first, which gives us 1000 times 3t minus 2 over t plus 0.5. This will help us get our vertical asymptote. In order to get it, we need to use our domain, or restriction, which is minus 0.5. We're gonna use two values of minus 0.5. One which is gonna be the right side of the minus 0.5, which is a number a little bigger than minus 0.5. So we're gonna evaluate it. $1,000, we open parentheses, 3 times minus 0.5 from the right, minus 2, over minus 0.5 from the right, plus 0.5. This gives us a total of 1,000. We open parentheses, minus 1.5 from the right, minus 2, over 0 from the right, which is minus 3,500 over 0 from the right, which approaches minus infinity.
In order to obtain the domain, we are going to take the number that cannot be used as a t and becoming this part a 0 as we cannot divide by 0. So we're going to make a 0 equals t minus 0.5. We're going to use only this part of the equation. Then we're going to move this t to the other side, making it a minus t equals minus 0.5, and then making it positive, making it t equals 0.5. So this number cannot be used in this equation, making it the domain x equals any real number except 0.5.
After getting all the information we need to graph, then we're going to graph. So we got the x-interception in 2/3, so we're going to mark it right here, 2/3, more or less. And the y-intercept will be at minus. The horizontal asymptote will be in 3,000, so that will be here. Now, the vertical asymptote will be at minus 0.5, so it will be something like this. Okay, now give it the graph, and it will look something like this. Okay, so we got here 3 questions. The first one says, in what year the population will be equal to 0? To solve this, we're going to see, well, when in the graph the population is 0, it will be in this point. So we got that the x-intercept is 2/3. Taking in account that, we can tell that the months, well, there are 12 months divided by 3, there are 4 months, and we got 2, so it's 8 months. So in the year 2000, with 8 months, the population will be equal to 0. Then, how many people will be there at 2006? So to solve this, we use the function we got at the beginning, saying that 3,000 multiplied by 6 minus 2,000 divided by 6 plus 0.5. This will be equal to 18,000 minus 2,000 divided by 6.5. So it will be equal to 16,000, divided by 6.5, which gives us a total answer of 2,416. Oh, sorry, 61. Okay, now to solve the last question that says how many people will be there at 2020, we're going to put here 20 and solve it. That gives us a total of 60,000 minus 2,000 divided by 20.5. So this will be equal to 58,000 divided by 20.5, which gives us a total of 2,829.
So we're going to get the behavior. We're going to do as x approaches to the 0 minus 0.5 from the left, the y we can see that it goes to infinity. When the x, as it approaches to minus 0.5 from the right, we can see that it goes to the minus infinity. So here we have the behavior. So here we can see that it is a rational function. A rational function is a quotient with two polynomials.